Hello students, I am Subhashish. Trigonometric identities are special rules that help us understand shapes and angles. Just as these rules show how different parts fit together, our own lives have hidden connections. For example, just like we balance work and rest like numbers in the rules, we also need to find balance in our lives. Just as these rules help builders make strong buildings, finding balance helps us build strong and happy lives. Just as these rules makes math easier, finding balance makes life simpler and happier. Learning outcomes. At the end of this lesson, you will be able to prove fundamental trigonometric identities using right triangles, transform trigonometric identities into alternative equal forms, apply trigonometric identities in solving equations and expressions. Keywords from this lesson are identities, equal forms, ratios, right triangle, equations, trigonometric identities. For all real values of theta, we have the following three identities. Sin square theta plus cos square theta is equal to 1. One plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosecant square theta. These identities are termed as three fundamental identities of trigonometry. We will now prove them as follows. Identity 1, sin square theta plus cos square theta is equal to 1. Proof. In right triangle OMP, we have OM by OP is equal to cos theta PM by OP is equal to sin theta. Consider it as equation 1. By Pythagoras theorem, we can say MP square plus OM square is equal to OP square. Consider it as equation 2. Dividing each term on the both sides of 2 by OP square, we get MP square by OP square plus OM square by OP square is equal to OP square by OP square. That gives MP by OP whole square plus OM by OP whole square, that equal to OP by OP whole square. From 1, we can say sin theta whole square plus cos theta whole square is equal to 1 square. Hence, sin square theta plus cos square theta is equal to 1. Now we will see second identity. 1 plus tan square theta is equal to secant square theta. In right triangle OMP we have MP by OM is equal to tan theta. OP by OM is equal to secant theta. Consider it as 3. From 2, that is Pythagoras theorem, we have MP square plus OM square is equal to OP square. Dividing each term on the both sides of 2 by OM square, we get MP square by OM square plus OM square by OM square is equal to OP square by OM square. That gives MP by OM whole square plus OM by OM whole square is equal to OP by OM whole square. From 3, we can write tan theta whole square plus 1 square is equal to secant theta whole square. Hence, 1 plus tan square theta is equal to secant square theta. Now, we will see third identity. 1 plus cot square theta is equal to cosecant square theta. In right triangle OMP, we have OM by MP is equal to cot theta, OP by MP is equal to cosecant theta. Consider it as 4. From 2, that is Pythagoras theorem, we have MP square plus OM square is equal to OP square. Dividing each term on the both sides of 2 by MP square, we get MP square by MP square plus OM square by MP square is equal to OP square by MP square. That gives MP by MP whole square plus OM by MP whole square is equal to OP by MP whole square. From 4, we can write it as 1 square plus cot theta whole square is equal to cosecant theta whole square. Hence, 1 plus cot square theta is equal to cosecant square theta. These identities can also be written as follows. Let us see one example. Prove that tan square theta minus sin square theta is equal to tan square theta into sin square theta. Solution. Consider tan square theta minus sin square theta. For second term, that is sin square theta, multiply and divide by cos square theta. We get tan square theta minus sin square theta by cos square theta into cos square theta. Sin square theta by cos square theta is tan square theta. So, by substituting, we get tan square theta minus tan square theta into cos square theta. Now take tan square theta as common. We get tan square theta into 1 minus cos square theta. We already know 1 minus cos square theta is sin square theta. We get tan square theta into sin square theta. Now we will see one more example. Prove that sin a by 1 plus cos a is equal to 1 minus cos a by sin a. Solution. Consider sin a by 1 plus cos a. For the given term, multiply and divide by 1 minus cos a. We get sin a by 1 plus cos a into 1 minus cos a by cos a. Then by multiplying the terms, we get sin a into 1 minus cos a by 1 plus cos a into 1 minus cos a. Apply a square minus b square is equal to a plus b into a minus b formula in denominator. We get sin a into 1 minus cos a by 1 minus cos square a. We already know that 1 minus cos square a is equal to sin square a. So, we get sin a into 1 minus cos a by sin square a. By cancelling, we get 1 minus cos a by sin a. Now, we will see another example. Prove that 1 plus cot square theta by 1 plus cosecant theta is equal to cosecant theta. Solution. Consider 1 plus cot square theta by 1 plus cosecant theta. Since cot square theta is equal to cosecant square theta minus 1, we get 1 plus cosecant square theta minus 1 by cosecant theta plus 1. Apply a square minus b square is equal to a plus b into a minus b formula in denominator. Apply a square minus b square is equal to a plus b into a minus b formula in numerator. We get 1 plus cosecant theta plus 1 into cosecant theta minus 1 by cosecant theta plus 1. By cancelling, we get 1 plus cosecant theta minus 1. Plus 1 and minus 1 will be cancelled. We remain with cosecant theta. Now we will see one more example. Prove that secant theta minus cos theta is equal to tan theta into sin theta. Solution. Consider secant theta minus cos theta. We know secant theta is equal to 1 by cos theta. So we get 1 by cos theta minus cos theta. By taking LCM, we get 1 minus cos square theta by cos theta. Since 1 minus cos square theta is equal to sin square theta, we write sin square theta by cos theta. Now we will write sin square theta as sin theta into sin theta. So we get sin theta by cos theta into sin theta. Sin theta by cos theta can also be write as tan theta. That is equal to tan theta into sin theta. Points to remember: trigonometric identities are fundamental rules in trigonometry that relate the ratios of the sides of a right triangle. These identities can be transformed into alternative equal forms, allowing for the simplification of trigonometric expressions and equations. Trigonometric identities are sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosecant square theta. Thanks for watching.